Hello friends, so here is another question on energy and power signals. So it has been asked to determine whether the signal xt equals to the rectangular pulse function, okay, which is rect t by tau, whether it is an energy or power signal. So first, the rectangular pulse function, which is represented as this. Minus tau by 2, 0, and this is equal to, here the value of a is equal to 1, so it is 1, it is t by tau, this. So the signal exists, okay, only in between minus tau by 2 to tau by 2, okay. So first we have to find out, let's, the energy of this rectangular pulse function. Energy of the signal minus phi to phi xt square dt. Here we have to change the limits of integration because the signal exists only in between minus tau by 2 to tau by 2. Everywhere else it is 0. So here we'll change the limits of integration from minus tau by 2 to tau by 2. In between that, the value of the signal, the function, is equal to 1 square dt. Everywhere else it is 0, that is from minus phi to minus tau by 2, and from tau by 2 to infinity it is 0. So this is the signal. So this is equal to minus tau by 2 to tau by 2 dt, which is equal to t tau by 2 minus tau by 2, which is equal to 2t by tau, 2 tau by 2, which is equal to tau. Okay, E is equal to tau, which is a finite value because there should exist some value of tau here which will be specified. So this is a finite value. Energy is finite. Then power. Power is equal to limit t tends to infinity 1 by 2t minus t to t xt square dt. Again, as I have said in all the previous solving all the previous questions related to this portion, okay, of the expression of power of a signal, this portion, this is equal to energy of the signal, because here limit we have taken is t tends to infinity. So here it is similar to minus phi, it is similar to writing minus phi to phi xt square dt, which is nothing but energy of the signal. So whether you write it in this form, limit t tends to phi minus t to t xt square dt, or directly minus phi to phi xt square dt, it means the same. So here it is basically limit t tends to infinity 1 by 2t into E, okay, E, this is the energy, which is equal to limit t tends to infinity 1 by 2t into the value of E which we calculated here, which is equal to tau. So here it is limit t tends to infinity tau by 2t. So here it is a finite value, here it is equal to infinity, be tau by infinity, which will be equal to 0. So here the power of the signal is 0. So here if you see, energy is finite, power is 0, so this is basically an energy signal, okay, it is a energy signal because it has finite energy and average power is 0. So this satisfies the condition of energy signal. Finite energy, power should be 0. Okay, for a power signal it is finite power, infinite energy. Okay, so this is an energy signal. The rectangular pulse function given, it is an energy signal. Okay. Hello friends, so here is another question on energy and power signals, and we have to determine whether the signal xt, which is the product of rectangular pulse function rect t by tau and a sinusoidal signal with angular frequency omega subscript O sin omega 0 t, whether it is an energy signal or power signal. Okay, so first we have the rectangular pulse function, which is represented as this, minus tau by 2 to plus tau by 2. It is in the form of a rectangular pulse of value 1. This is rect t by tau. We have already discussed about the basic signals involved in signals and systems. This is multiplied with the sinusoidal signal. Okay. Like this. Okay. This is sin omega 0 t. So when it gets multiplied with these two, now for t greater than tau by 2, it is 0. For lesser than, okay, minus tau by 2, this is 0. Okay, it is 0 here on this side, the negative time side, which is lesser than minus tau by 2. So here when these two signals get multiplied, this is 1 minus 1, okay, here. So when these two signals get multiplied, we will have a resultant signal which is something like this, which will only exist in between minus tau by 2 to tau by 2. Maybe something like this. Okay, minus tau by 2, here it is tau by 2, and everywhere else it is 0. Okay, it is 0. Okay, this is sin omega 0 t multiplied with rect t by tau. Okay, so this is basically a sinusoidal signal restricted within the limits minus tau by 2 to tau by 2. So first we'll determine the energy of this signal, the resultant signal. Okay, energy, we know it is equal to limit t tends to phi. You can write it in that form, or you can write it directly as minus phi to phi x t square dt. Okay, so here rect t by tau is nothing but 1. It is getting multiplied with 1. So here we have to change the limits of the integration. The resultant is a sinusoidal signal in between minus tau by 2 to tau by 2. This, so it is minus tau by 2 lower limit, tau by 2 plus tau by 2 upper limit, and sin omega 0 t multiplied with 1, which is basically minus tau by 2 okay dt sin, it is square, okay, sin square, because xt square, sin square omega 0 t, okay, dt, this, okay, this xt square, okay. So here we can write it as, okay, I'm starting from here, minus tau by 2 to tau by 2. We will use the trigonometric identity 1 minus cos 2 omega 0 t by 2, that is equal to sin square omega 0 t dt. If you remember the trigonometric identity, 1 minus cos 2x by 2 is equal to sin square x. We have used that. So sin square omega 0 t dt is nothing but 1 minus cos 2 omega 0 t by 2. Okay, this. So this will be again, will be equal to integration 1 by 2 taken outside minus tau by 2 dt minus 1 by 2 minus tau by 2 cos 2 omega 0 t dt. Again, I have highlighted this in the previous questions also, that when we integrate a sine or cosine function over one complete cycle, okay, 0 to tau or minus tau by 2 to tau by 2, then the resultant value of the integration will be 0. Why? Because see here, we will highlight this here. So here the area which is occupied by the positive half cycles here, okay, this, let me use a different ink, okay, red, the area occupied by the positive half cycles, this one and this, okay, 2 complete positive half cycles and 1 half, 2 plus 1 by 2 in the positive side, okay, then negative half cycles here, okay, same magnitude but in the opposite direction. This one 2 complete negative half cycles and half of the complete cycle, okay, half of the negative half cycle, same 2 plus 1 by 2 in the negative side. So when we add them together, they cancel each other out and the net result is 0. So here when we integrate a sine or cosine function over one complete cycle, then the resultant will be 0. Okay, I have explained it in the first question related to energy and power signals, you can check it out there. So this will be 0. So here it will be simply 1 by 2 integration of dt, it will be t, it will be tau by 2 to minus tau by 2, which is equal to 1 by 2 into, this will be tau by 2 plus tau by 2, which will be tau, okay, it will be tau by 2. The energy is tau by 2, which is a finite value. It is a finite value. Now, power of a signal is limit t tends to infinity 1 by 2t minus t to t xt square dt. So basically this portion minus t to t xt square dt with limit t tends to infinity is nothing but the energy, this, okay, this. So whether you write it as limit t tends to infinity minus t to t xt square dt or directly in this form minus phi to phi xt square dt, both of them are the same, okay, this and this. So basically here it is, power is equal to limit t tends to infinity 1 by 2t into E, okay, which is equal to limit t tends to infinity 1 by 2t into tau by 2, okay. Here t is infinity, tau by 2 is a finite value. So here it will be finite value by infinity, which will be equal to 0. So power is equal to 0. So here in this function, energy we got a finite value, power is 0. So this satisfies the requirement of energy signal. Finite energy, 0 average power. This is a energy signal. So this function, which is the product of the rectangular pulse function and sinusoidal function, this is an energy signal. Okay. So friends, I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.